Today I will show you how to input borehole defect data, get instant GSI calculations at each joint location, automatically classify weathering grades, generate 2D subsurface profiles, and streamline your workflow with CVS Import Export. Let's dive in. Here, this is how the GSI calculator looks like. First, let's understand what we are calculating. The Geological Strength Index or GSI is a rock mass classification system developed by Albert Hook and his colleagues. It's essential for estimating rock mass strength using the Hoek-Brown criteria, tunnel support design, slope stability analysis, and foundation design in rock. Traditionally, engineers estimate GSI visually using charts like the one shown in this slide. But this approach has some problem. It's subjective. Different engineers get different values. It doesn't capture variation with depth. It's difficult to justify in reports. Our GSI calculator solves these problems using the quantitative GSI method based on measurable joint parameters. In Hook and Brown failure criteria, the GSI is one of the most important parameters. GSI is used to calculate constant values like for S and A as shown in this slide. It is also used in determining modulus of deformation of rock masses. Therefore, GSI is very important input parameter, the variation of which may affect the properties of rock mass leads to wrong design. The equation shown in this slide has been used to determine GSI. But for determining GSI, other parameters are required to know. The beauty of this method is that it uses measurable parameters from your borehole logs, things you have already recorded in the field. The parameters are joint location, surface roughness, joint shape, waviness, coatings, and alteration. The GSI calculator automatically derives the factors values from your descriptive inputs, so you don't need to memorize tables. Get started. Let's open the GSI calculator. You can access it from home page or the main navigation menu. Here's what you will see. At the middle left portion, there are borehole tabs, and on the right, there is a tab for creating multiple boreholes. We even have other tabs for NSL or borehole, soil depth, northing and easting tabs. Here we can provide soil depth as one of the input parameter as our calculator works only on rock cores. Now let's talk about GSI table, where you will input your defect data. Left side is the input values and on right is for output results. After this slide, we will see the tables of different defect conditions, which are the input values. The interface is designed to mirror your field logging work, so data entry feels natural. The additional functions are what you can export your data through CES files. After corrections or adding data in your CVS files, you can import the same file into the calculator. Entering defect data. Let's see what input data made up of. The table has the following columns. Column 1 is about joint RL. This is the depth where the defect was logged. Column 2, actual joint depth. Here, first defect is considered at the interface of soil and rock. Column 3 is about RQD, rock quality designation, calculated between consecutive joins. This updates automatically as you add more rows. Here RQD is calculated at every 500 millimeters. Column 4 to 8, we will discuss it in the next slide. Entering defect data. Column 4 to 8 shows in this calculator are about defect conditions. Column 4 is about defect type as shown in this slide at table 1. It consists of joint, partings, shear surface, shear seam, and fault. Column 5 is about defect orientation. Here angle is measured from the horizontal. The column 7 is about the roughness of joints and shown in figure 2. Column 6, column 7 is about the defect shape. It describes the joint surface geometry, like planar, slightly undulating, very stepped, and the details are as shown in table 3. Column 8 is about coatings and composition between the joints. Here we will input different types of coatings between the joints. All the details are provided in table 4. This slide gives us an idea to how to use borehole logs in this calculator. Figure A shows that the soil depth is up to 6.85 meters, and afterwards this depth rock starts. Figure B shows the depth-wise defect conditions. This part of log is very important for defining defects condition. If this section is not well defined, then the results of this calculator may not be right. This slide shows us output results. Here first 3 columns are the ratings of the defect conditions explained in slide 8. In next 4 columns, we calculate parameters through ratings of different defect conditions which are explained above. And lastly, the last 2 columns are the columns where GSI and weathering conditions of the borehole are shown along the depth.